Dear students, previous class we discussed about an infinite series and nth term test, also Cauchy's criteria for a series. Now let us discuss about the test of or the convergence of the P series. Test the convergence of P series means here sigma 1 by n power p. Consider the series, infinite series, sigma 1 by n power p is convergent if p greater than 1. Convergent if p greater than 1 and diverges if p less than or equals 1. So, this is an important test. Sigma 1 by n power p. Test for convergence of P series. Sigma 1 by n power p. Convergence when p greater than 1 and diverges if p less than or equals 1. So, how to prove this one? Listen. When p equals 1, what happens? When p equals 1, the series sigma 1 by n power p reduces to sigma 1 by n. That's a harmonic series. We all know that harmonic series is always divergent. Why? Because in previous class we proved this one. Sigma 1 by n is divergent. Okay. When consider the partial sum Sn equals 1 plus etc. plus 1 by n. S2 power n is 1 plus 1 by 2 plus etc. plus 1 by 2 power n. Then clearly S2 power n is unbounded. Hence even Sn is unbounded. Therefore sigma 1 by n is divergent. In previous class we discussed it. Now, so when p equals 1, sigma 1 by n diverges, the result holds. Now, when p less than 1, when 0 less than p less than 1, p lies in between 0 and 1. When p less than 0 less than p less than 1, we have n power p strictly less than n. N power p strictly less than n for all n. That means 1 by n power p greater than 1 by n. 1 by n power p strictly greater than 1 by n. Now we know that the sequence of partial sums of sigma 1 by n. Now again in previous class we already discussed that the sequence of partial sums of sigma 1 by n is unbounded. Therefore, the sequence of partial sums of sigma 1 by n means, or sigma 1 by n power p greater than 1 by n means sigma 1 by n power p strictly greater than sigma 1 by n. Okay. But in previous class we see that the sequence of partial sums of sigma 1 by n is unbounded. Therefore, according to this inequality, we see that the sequence of partial sums of sigma 1 by n power p is also unbounded. It is also unbounded. So, the partial sums of sigma 1 by n power p is unbounded means the sequence of partial sums of sigma 1 by n power p is divergent. So, the sequence of partial sums of sigma 1 by n power p is divergent means sigma 1 by n power p is divergent. So when n equals 1, the sequence reduces to harmonic series. Sorry, the series sigma when n equals 1, the series reduces to harmonic series. We know that it is divergent. When p lies in between 0 and 1, then when p lies in between 0 and 1, then we have n power p less than n, 1 by n power p greater than 1 by n, sigma 1 by n power p greater than sigma 1 by n. But we know that the sequence of partial sums of sigma 1 by n is unbounded. Therefore, sequence of partial sums of sigma 1 by n power p is unbounded. Therefore, sequence of partial sums of sigma 1 by n power p is divergent. Therefore, sigma 1 by n power p is divergent. So, when p less than or equals 1, sigma 1 by n power p is divergent. Clear? Okay. Now, when p greater than 1, what happens? That is the second argument. When p greater than 1. So, let the sequence Sn let secant Sn be the sequence of partial sums of the series. Sequence of partial sums of the series sigma 1 by n power p for p greater than 1. Then for p greater than 1, then clearly the sequence Sn is an increasing sequence. Okay, what is S1? S1 is when p greater than 1, Sn be the sequence of partial sums of sigma 1 by n power p. Clearly secant Sn is an increasing sequence. Now choose Kn. Let Kn equals Kn equals 2 power n minus 1 for n equals 1, 2, 3, etc. Okay. So what is K1? K1 is 3. Agreed? Okay. What is K2? K2 is 7. Agreed? Sorry, K1 is 3. K2. What is K1? K1 is 1. Not K1. Sorry. K1 is 1. What is K2? K2 is 3. What is K3? K3 is 7 and so on. Agreed. Now, what is SK1? SK1 equals, what is K1? 1. So it is S1. What is S1? S1 equals 1. Agreed? Sn be the sequence of partial sums of the series sigma 1 by n power p. When p greater than 1, secant Sn is an increasing sequence. That Kn is 2 power n minus 1, then Sk1 is S1 equals 1. Agreed? Okay. What is Sk2? Sk2, what is K2? 3. S3, what is S3? It is 1 plus 1 by 2 power p plus 1 by 3 power p. This is S3. Enough? Sn, what is Sn? 1 plus 1 by 2 power p plus 1 by 3 power p plus etc. plus 1 by n power p. That is Sn. So S3 is 1 plus 1 by 2 power p plus 1 by 3 power p. So it is strictly less than 1 plus 1 by 2 power p plus 1 by 2 power p. Clear? Okay. That is equals, it is 1 plus 2 by 2 power p means 1 plus 1 by 2 power p minus 1. So Sk2 strictly less than 1 plus 1 by 2 power p minus 1. What is Sk3? Sk3, what is K3? 7. So it is S7. S7 means 1 by 2 power p plus, 1 plus 1 by 2 power p plus 1 by 3 power p plus 1 by 4 power p plus 1 by 5 power p plus 1 by 6 power p plus 1 by 7 power p. Agreed? So it is strictly less than 1 plus 1 by 2 power p plus 1 by 2 power p. Okay? Plus 1 by 4 power p plus 1 by 4 power p plus 1 by 4 power p plus 1 by 4 power p. Clear? Okay. That equals 1 plus 1 by 2 power p minus 1. 1 plus 1. Plus, here it is 4 by 4 power p. 4 by 4 power p means again 1 by 4 power p minus 1. Okay? Yes. That equals 1 plus 1 by 2 power p minus 1 plus 1 by 2 into 2 power p minus 1 whole square. Why? This 4 power p minus 1, consider this step. 1 by 4 power p minus 1, that is 1 by 4 means 2 square. 2 square whole power p minus 1. That equals 1 by 2 power p minus 1 whole square. Clear? So Sk3 is strictly less than 1 plus 1 by 2 power p minus 1 plus 1 by 2 power p minus 1 whole square. Clear? Yes. So proceeding like this, what is Skr there? So if you proceeding like this, then Skr, clearly Skr strictly less than 1 plus 1 by 2 power p minus 1 plus 1 by 2 power p minus 1 whole square plus etc. plus 1 by 2 power p minus 1 all power r minus 1. Clear? Okay. So that means it is again skr strictly less than 1 plus 1 by 2 power p minus 1 plus 1 by 2 power p minus 1 whole square plus etc. Okay, putting r equals this one. Let r equals 1 by 2 power p minus 1. So this is an infinite series equals 1 plus r square plus etc. Having since r less than 1, sure, okay, r less than 1, it's an infinite geometric series having sum 1 minus 1 by r equals, 1 by 1 minus r. So skr strictly less than, finally skr strictly less than 1 by 1 minus r. That means sequence skr is bounded. Okay, sequence skr is bounded. Sequence skr is a subsequence of the sequence Sn, so that implies sequence Sn is bounded. Sequence Sn is bounded. Sequence Sn is bounded. Sequence Sn is an increasing sequence. Then by monotone convergence theorem, sequence Sn is convergent. Agreed? Sequence Sn convergent. What is sequence Sn? The sequence Sn be the nth partial sum of the series sigma 1 by n power p, that is convergent. Then we have the series sigma 1 by n power p is convergent when p greater than 1. Enough. So this is the proof of test of convergency for the p series. That is sigma 1 by n power p converges when p greater than 1 and diverges when p less than or equals 1. Clear? By using this argument, what about sigma 1 by n square? Sigma 1 by n power p convergent when p greater than 1. So what is sigma 1 by n square? Test the convergence of sigma 1 by n square. Here p equals to greater than 1. So by p test sigma 1 by n square is convergent. What is sigma 1 by n? Harmonic series. Sigma 1 by n. Here p equals 1. We already proved. When p equals 1, it is diverges. Okay. What is sigma 1 by root n? Sigma 1 by root n means sigma 1 by, what is root n? N power half. What is p? Here p equals half less than 1, so it is diverges. So this is the significance of p series test. Clear? So the result is important. Sigma 1 by n power p convergent when p greater than 1 and diverges when p less than or equals 1. Clear? Okay. So we know that the harmonic series sigma 1 by n is diverges. What about the convergency or divergency of alternating harmonic series? We know that the harmonic series sigma 1 by n diverges. Alternating harmonic series means it is sigma minus 1 power n plus 1 by n. This is alternating harmonic series. Sigma with respect to n means n ranges from 1 to infinity. It is known as alternating harmonic series. Sigma with respect to n minus 1 power n plus 1 by n. Alternating harmonic series. Is it converge or diverge? So for actually what about this one? Sigma n ranges from 1 to infinity minus 1 power n plus 1 by n is, come on, when n equals 1, what happens? It is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. Clear? So let Sn be the sequence of partial sum. So let Sn be the sequence of partial sum of sigma minus 1 power n plus 1 by n, the given series. Then what about S2n? S2n equals 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. plus 1 by 2n minus 1 plus 1 by 2n plus 1 by 2n minus 1, sorry, not a plus, just minus, yes, 1 by 2n minus 1 minus 1 by 2, 1 minus 1 by 2 plus 1 by 3, even, odd terms or all terms are positive, or when odd denominator All of the terms are positive. So 1 by 2n minus 1 positive, even denominator negative, 1 minus 1 by 2n. So s to n is this one. You can associate this s to n. That is, it is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. plus 1 by 2n minus 1 by 1 by 2. Okay? Clearly, this s to n is an sequence s to n is an increasing sequence. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 all are positives. So clearly s to n is an increasing sequence. Agree? What is s to n plus 1? S to n plus 1 is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. plus 1 by 2n minus 1 minus 1 by 2n plus 1 by 2n plus 1. Clear? Okay. Equals, it is 1 minus of 1 by 2 plus 1 by 3, sorry 1 minus of 1 by 2 minus 1 by 3, then minus of 1 by 4 minus 1 by 5 minus etc. minus 1 by 2n minus 1 by 2n plus 1. Okay, right. Clearly, this s to n plus 1, secant s to n plus 1 is a decreasing sequence. All the terms inside this bracket are negative. So, s to n plus 1 is a decreasing sequence. That means we have, so s to n is an increasing sequence, s to n plus 1 is a decreasing sequence, then we have 0 less than s to n. But this s to n strictly less than s to n plus 1 by 2n plus 1. Okay? What is actually s to n less than s to n plus 1 by 2n plus 1? 1 by 2n plus 1 is a positive quantity. What is s to n plus 1 by 2n plus 1? That is s to n plus 1. Agreed? So it is 0 less than s to n less than s to n plus 1. 0 less than s to n less than s to n plus 1. What is this s to n plus 1? S to n plus 1. What is s to n plus 1? 1 minus of this one. S to n plus 1 is 1 minus of this one. 1 minus of this one means this should be less than 1. So 0 less than s to n less than s to n plus 1 less than 1. That means sequence s to n 0 less than from here. What do you get? So here from there 0 less than s to n less than 1. 0 less than s to n less than 1 and 0 less than s to n plus 1 also less than 1. Means sequence s to n and sequence s to n plus 1 are bounded. They are bounded sequence. Sequence s to n and sequence s to n plus 1 are bounded. Therefore, they are convergent. They are the s to n and s to n plus 1 are any two subsequences of, they are s to n and s to n plus 1 are the two subsequences of this Sn. Then, since they are bounded and they are monotonic, hence they converge to same limits. Okay, same value. That means secant Sn is convergent. Secant Sn convergent. What is secant Sn? Secant Sn is the partial sums, sequence of partial sums of sigma minus 1 power n plus 1 by n, the alternating harmonic series. Since secant Sn is convergent, then sigma n ranges from 1 to infinity minus 1 power n plus 1 by n is converges. So see, the alternating harmonic series converges even though harmonic series diverges. Harmonic series sigma 1 by n diverges, but its alternating harmonic series sigma minus 1 power n plus 1 by n always converges. Clear? Okay. So now we introduce two tests, or now we discuss about two tests. One is nth term test, that is sigma xn converges, then limit xn equals 0. That's the first test of convergency. Nth term convergency. Nth term convergency means sigma xn converges implies limit xn equals 0. Reverse inclusion need not be true. When limit xn equals 0, that need not be implies sigma xn converges. Second test is P series test. That is sigma 1 by n power p converges if p greater than 1 and diverges if p less than or equals 1. Okay. Now come to an important test of convergency, that is known as comparison test. That is known as comparison test. What is comparison test? Comparison. If x equals xn, the test states the comparison test. If x equals xn be a sequence of real numbers, a real sequence, and suppose that there exists term k fallen n, k is a natural number, such that 0 less than or equals xn less than or equals yn for all n greater than or equals k. 0 less than or equals xn less than or equals yn for all n greater than or equals k. Then the test states that convergence of sigma yn means sigma yn converges implies convergence of sigma yn implies convergence of sigma xn. Convergence of sigma xn means when sigma yn converges, then sigma xn converges. That is the first argument. First one, when sigma yn converges, then sigma xn converges. Its second argument is when sigma xn diverges, then sigma yn diverges. So this is comparison test. Let x equals xn be a sequence of real numbers. There exists a k fallen n such that xn ranges from 0 to yn. Then sigma yn converges, then sigma xn converges. If sigma xn diverges, then sigma yn diverges. Clear? How? The proof is immediate. Listen. First suppose that sigma yn converges. Sigma yn converges. Sigma yn converges means for all epsilon positive, there exists a capital M fallen n such that modulus of yn plus 1 plus etc plus ym strictly less than epsilon